This course will help someone with no technical knowledge understand how the internet works. Ian Frost teaches this course with tons of visuals, just like he has taught thousands of people on Udemy.
The internet is a part of our daily life and we use it constantly. But what is the internet? Have you ever really thought about it? Have you ever wondered what happens in the background when you enter a web page? If your answer to all these questions is yes, you are definitely looking at the right course. In this course, I assume you don't know anything, and I am slowly explaining what the internet is. You don't need any prior knowledge to follow this course, since this course tells you everything from scratch with many abstractions. These abstractions will allow you to understand the subject without knowing details. I think everyone who uses the internet should know its basic features. Everyone who uses the internet needs to know the ISP. Everyone who uses the internet needs to know that the internet is just cables spread all over the world, and in this course we will go on a journey together and we will look at all these concepts in a very visual way. I mean, you will see exactly how the internet works with your eyes. In addition, at the end of the course, there are some questions related to this course, and by answering them, you can benefit from this course at the maximum level, okay? Regardless of your age or profession, this course is for everyone. You will absolutely understand what the internet is when you finish this course. So, let's dive into it. Now, we are going to talk about a scenario. Let's say you are the system administrator of a small company and your boss wants you to enable all these computers to communicate with each other. I mean, PC1 should be able to communicate with PC7, or PC5 should be able to communicate with PC4, and so on. You got the point, but the question is, how do we do such a task? And this is where the switch device comes into play. The switch is the device we use for computers in the same environment to communicate with each other. When I say in the same environment, what I mean is that I am talking about computers in the same office, house, or at very close distance to each other. And this scenario is a good example for such a situation. There's an office, and in this office we have 7 computers that communication of them is required. Wonderful. We have a switch to accomplish the communication of computers. This is good. However, the question is, can these 7 computers communicate with each other right now? And the answer is big no. Because first of all, these 7 computers need to interact with the switch somehow. But how can we do that? I know that you have some ideas, and you are probably guessing right. We must use cables to connect computers to the switch. As you can see, we are connecting all the computers to the switch with the help of cables. We generally use copper cables for this task, and the type of these copper cables can generally be Cat5 cable or Cat6 cable in small environments. By the way, Cat6 cables are faster than Cat5 cables, and Cat represents category, okay? On the other hand, in addition to copper cables, some switches support fiber optic cables as well, and it is important to note that fiber optic cables are generally much faster compared to copper cables in data transmission. This is very important. And for switch devices, there is a crucial point to be aware of. Please note that if there is a switch in the environment, and if we want to connect computers to that switch, we must definitely use a cable that is generally a copper cable or fiber optic cable. What I am trying to say is, with wireless technology, you cannot connect computers to a switch. Switches only work with cables. This is very vital, guys. If you want to use a switch device, you have to use cable to connect your devices to the switch. It's that simple. However, if you want to connect computers in the same environment to each other by using only wireless technology, you can use an access point device instead of a switch device. I mean, you can use both a switch device or an access point device in order to connect all these 7 computers. Both of them separately is acceptable for this purpose. The only difference between these devices is access points use wireless technology while switches use cables, okay? There are 7 computers in this environment, and we can connect these 7 computers by using switches and cables just like you see in the picture. Or in the same way, we can use an access point device instead of a switch device, and if we use an access point device, access point uses wireless technology instead of cables while communicating with devices. In summary, both the switch device or an access point device enable these 7 computers to communicate, this is obvious, but one uses cable and the other one uses wireless technology. Anyway, what I just want you to know right now is we generally use copper cables in order to connect computers to the switch in the environment such as a home or office. By the way, I want to focus on the switch device instead of the access point device in this course. Very good. And at this moment, all these computers can communicate with each other with ease because they connected to the switch by using cables, and this means that they created a network. In other words, the reason that these computers can communicate with each other is all of them are in the same network, and we call this special network as local area network, or briefly LAN. A local area network is a collection of devices connected together in one physical location, such as a building, office, or home. As I just said, if we want to create a LAN, this location must be a restricted location in terms of area. I mean, you cannot create a LAN between computers located in United States and computers located in Russia. On the other hand, this area is very suitable area in order to create a LAN. Therefore, these computers can communicate with each other because all of them are on the same LAN with the help of this switch. So, we can deduce that if we want to create a LAN, we need a switch device. By using a switch device, we can create a local area network. And if we consider the millions of local area network all over the world, we can easily understand how important a switch device is. You might think that all the houses in the world are actually a local area network. You have a LAN in your house, or your neighbor's home also has a LAN, or there is also a LAN in the office where you work, okay? You catch the idea. And now, let's take a closer look at the communication of computers and what this event actually represents. Let's say PC1 wants to send a message to the PC6. By the way, the messages generated by computers has a few special names. Some people call them as packet and some people call them as frame. Both of them is okay, but in this course I prefer to use packet instead of frame. Okay, PC1 will send a packet to the PC6. As you see in the visual, the packet firstly goes to the switch, and then the switch looks at the inside of the packet and learns the destination of the packet, and finally the switch sends the packet to its destination. And if PC1 can send a packet to the PC6, this means that PC1 and PC6 can communicate with each other. The logic is basically this. If a computer can send a packet to another computer, this refers to these two computers are on the same network and they can communicate with each other. This information is so crucial, guys, okay? However, maybe by looking at only this switch image, what the switch device actually is may not be fully visualized in your mind. For this reason, we will now examine this slide for you to understand the event better. This is the real version of a switch device, and as you can see, there are many ports on a switch device. This is important. Also, the number of ports varies from one switch device to another switch device. I mean, different switches have different numbers of ports. Some switches have 10 ports, while some switches have more than 20 ports. And of course, this generally leads to an increase in price. Okay? By the way, these ports have a special name and they are called LAN ports. This probably makes sense to you because, as you know, we create LANs by using switch devices. For this reason, I think it is so reasonable to call these ports LAN ports, because by connecting these computers to these ports, we can create a LAN. And in addition to this, there are LAN ports on the back of our computers or on the side of our laptops, just like these LAN ports. You can see the related visuals on the right side. And to establish a connection between computers and the switch, we connect the LAN port on the computer and the LAN port on the switch with the help of a cable. So let's do this. Let's start with this port and PC1. Then let's connect this port and PC2. After that, let's connect this port and PC3. And finally, I want to make a connection between this port and PC4. Wonderful. And currently, these computers can communicate with each other. But how exactly does this communication happen from a switch perspective? Let's take a look at this. Let's say PC1 wants to communicate with PC4. So it will send a packet to the PC4. This packet will go to this port of the switch first, and there we go. Afterward, that port will give the packet to the hardware inside the switch. Okay? Then the switch will look inside this packet and learns its destination. After that, the switch gives this packet to this port that is connected to PC4. And finally, the switch sends the packet to the PC4. Okay? Wonderful. And to summarize, currently we have connected these 4 computers to each other thanks to this switch. This means we have created a local area network, and these computers can easily communicate with each other since they're on the same LAN. I hope everything is quite good so far, and the switch device is visualized better in your mind thanks to this slide. But there is a little issue here. Let me explain. If you are aware, our computers were in the same network, and we have only talked about the communication between those devices. We have never talked about how these computers can connect to the internet, right? So the question is, can these computers communicate with the internet just by having a switch device? And this, my friends, will be the question that we are looking for an answer in the next lesson. See you guys soon. Bye. In our previous lesson, we briefly talked about how to connect computers in an office and how do we create a network. And I said that we can create a LAN with the help of a switch device. But the problem is, currently these computers can only communicate among themselves. They cannot communicate with the internet, because the only task of the switch is to create a LAN and enable the communication of the devices in the same LAN. Great. And by the way, I would like to remove this LAN statement from the visual because you can understand that there is a LAN here. Thus, we can work more comfortably. Wonderful. And the main question is, how do we connect these computers to the internet? And this is where the router device comes into play. Let me explain. The main task of the router is to enable computers to connect to the internet. Without a router, it is impossible for us to connect to the internet. And in order to provide this connection, in order to provide a connection to the internet, first of all, we must connect this switch to this router. And this cable is a copper cable, just like other cables. This is good, but currently, what we have to do isn't over. We still can't connect to the internet in this situation, because we need a connection between the router and the internet as well. And as you know, a special cable comes to our homes or offices, and this cable is given us by internet service provider. And thanks to this cable, we connect to the internet. If you have never heard of Internet Service Provider, don't worry, we will talk about it in detail. But for now, all you need to know is the Internet Service Provider is giving us this cable for a certain amount of money so that we can connect to the internet easily, okay? So currently, we have everything necessary to connect to the internet by using these computers. Hence, let's see the basic tasks of the switch and the router one by one on the animation. These 7 computers in the office can communicate with each other thanks to the switch. For example, let's say PC1 wants to communicate with PC5. For this purpose, PC1 will send a packet to the PC5. So, as you know, the packet firstly goes to the switch, and afterward, the switch learns the destination of the packet, and finally, the switch sends the packet to its destination, and there we go. This is how 2 computers in the same LAN communicate with each other. And please always remember, a switch device is enough for us in order for communication of devices in the same LAN. On the other hand, a router has no role in the communication of different devices in the same LAN like PC1 and PC5. This is very vital, okay? I hope I could explain the event. And however guys, what if PC1 wants to communicate with the internet? In other words, what will happen if PC1 wants to send a packet to the internet? Let's see. First of all, you should remember this information. If a computer can send packets to the internet, this means that this computer communicates with the internet. Frankly speaking, I believe that you exactly understand the logic of this event anymore. If we can send packets from one point to another point, these 2 points can communicate. It's that simple. But the question is, how will PC1 send packets to the internet? To be able to do this, first, PC1 must send its packet to the switch just like before, because there is no other way for PC1 to be able to reach the router, right? I mean, if PC1 wants to send a packet to the internet, this packet must reach the router no matter what, because the router is a door to access the internet. This is obvious. Hence, if PC1 wants to communicate with the router, it must send its packet to the switch first. After that, the switch looks at inside of the packet and understands that the packet wants to go to the internet. So, it sends the packet to the router, and there we go. And then, the router firstly looks at the inside of the packet and understands that the packet wants to go to the internet. And afterward, it sends the packet to the internet over this port. And there we go. By the way, if you are aware, we have plugged this cable that we purchased from the ISP into this port. This is obvious. I believe that currently you can easily imagine in an intuitive manner how the cables coming to the router like this or like this are plugged into the ports. I mean, there are some ports on the router and you need to put the cables into that ports. It's that simple. I will not show this visually because detailed information about the ports isn't important for you at this moment. You just must understand the logic behind the router, okay? And as a result, PC1 sent its packet to the internet. In other words, PC1 and the internet communicated. And the device that helps us to connect to the internet is the router. Wonderful. I believe that you understand the most basic tasks of the switch and the router, and I hope the animations have been useful for better understanding. However, I want to ask you 2 questions. My first question is, can you visualize the internet in your mind? And the second question is, what exactly does the internet mean? And these will be the questions that we are going to discuss in the next lessons. See you guys soon. Before discussing the meaning of connecting to the internet from a computer perspective, I think it is helpful to know what the internet exactly stands for, because if you are really starting from scratch, I mean, I assume that you are real newbies. You may not know exactly what the internet is. For this reason, I want to visualize the internet for better understanding. To do this, in this lesson, we are going to see how a packet moves on the internet. By the way, keep in mind that this model you see is a simplified model designed to make the concept easy to understand. So, this structure in real life is much more complex than you see in the visual. But with this simplified model, you will understand the logic of the event very well, I promise you. And I believe that's all you need right now. As you can see, there are many routers on the internet, right? And there's a special reason for this. So at this moment, I would like to give you another piece of information about a router. A router is a device required for a computer or electronic device to connect to the internet. You know this definition. On the other hand, you can think of the router as the device we use to communicate with a computer in another part of the world, or you can think of the router as the device we use to communicate with a computer in a different LAN. I mean, if you are aware, there is a LAN here, right? And there is another LAN here. This is obvious. Therefore, we can draw the following conclusion. Connecting to the internet actually can stand for connecting to the another computer located anywhere in the world. I mean, you can think of the internet as the structure that connects all the LANs all over the world. I want to repeat this again. You can think of the internet as a structure that connects all the LANs all over the world. And as you know, there are millions of LANs connected to the internet except these LANs. Wonderful. I hope that everything is good so far, but there's a thing that we need to consider. So, I want to ask you a question. Why are there so many routers here? Let me explain it in a simple manner. First, you should know that these routers are distributed around the world in an organized manner. However, routers aren't the only devices in this structure. This is important. There are thousands of routers and other different devices in this structure distributed pretty widely. But focusing on only routers is enough for us in order to understand the concept behind the internet. And the first question that comes to your mind is probably why routers are so important to the internet. As a matter of fact, the answer to this question is hidden in the core task of a router. The device we use to enable different LANs to communicate with each other is the router, right? And thanks to the internet, we can connect all the LANs in the world to each other, For this reason, it makes perfect sense to use many routers to connect millions of local area networks together. These LANs, you see, are just two of the millions of local area networks all over the world. In summary, if the internet must connect millions of local area networks, it is obvious that it needs routers. I hope you got this. And once you understand the importance of the router for the internet, you probably think of another question. And the second question that probably comes to your mind is why there are so many routers instead of just one router. And I think this is a more critical question than the first question, and let me answer it on the visual. But before answering this question, there is something in this picture that should catch your attention. Please look carefully at the picture and try to find this difference. As you can see, these LANs on the visual have one device instead of a switch and a router. So, if there is no switch in the environment, how can there be a LAN? Or, if there is no router in the environment, how can it be connected to the internet? And this is where the home router comes into play. A home router is a combo device consisting of a router and switch combination. Hence, these devices in the LANs are a mix of the switch and the router. This means that if we have a home router, we don't need an additional switch and router. This device is enough for small environments like a home or small office. This is important. I want to repeat this again. A home router is enough for us in small environments, or if there are very few devices in the environment. Okay? I showed you a home router because most of you have these devices in your home and you connect to the internet by using home routers. For this reason, I wanted to tell you what these devices are in order to avoid confusion. However, please note that if there are too many devices in the environment, the home router will be insufficient and you may need additional switch and router. You catch the idea. And now, let's go back to our question. Why there are so many routers instead of just a single router? Imagine that there is a single router in the middle of the world instead of thousands of routers distributed all over the world. In this case, millions of electronic devices around the world would have to be connected to the same router. This is obvious. This means that this single router needs millions of ports, isn't it? And it is impossible to design such a device. But this is not the only problem. In addition to it, if there was only one router, the entire lot of all devices in the world would be on that router. And this is another problem because in computer science, we don't want to give all the load on a single point. We even call this problem the single point of failure. And this is a problem that needs to be considered. To be able to teach it better, let me give you an example. Imagine this router is broken somehow. This means that the internet of the whole world is crashing down at the same time, right? Because we only use a single router to connect all LANs around the world. The router broke down and the whole internet crashed down. It's that simple. Just think about the consequences of this problem in a second. This would be terrible, right? And so far, we have talked about two vital problems, but it isn't over. Another major problem is the cable length problem. Imagine how long the cable must be if there was only one giant router in the middle of the world. Especially LANs that are the furthest from the giant router would need very long cables. This is obvious, right? Therefore, this design is a very problematic design. And the solution for all these problems is this distributed structure all over the world. You catch the idea. But to make sure you fully understand the main logic of this structure, I want you to do an exercise. I want you to determine why such a structure eliminates the problems we talked about shortly before. I'm sure that you can handle this. Just do it, guys. I asked you a question at the end of the previous lesson, and I know that you were all analyzing the situation, but let's do it together just in case. As you know, if we used a single router at the middle of the world, we would have problems with the overloading of the router. On the other hand, we would need many long cables for LANs that are the furthest from the giant router. But as you can see in this structure, the cables don't have to be that long, and this is an important advantage. Actually, of course, we can need long cables in this structure too, but not as much as in the other structure. After all, in this structure, there can be many kilometers between two routers. This is reasonable. However, this is by no means laying cables from one end of the world to the other end, right? And while we only connect two routers with one cable in this structure, we will connect millions of LANs to the giant router in the other structure. So, we will need a lot of very long cables to a single point. And it creates a huge mess. Imagine cables coming to the giant router from millions of LANs that locate in the furthest area. You got the point. By using this structure, we minimize the cable mass and we avoid overloading of a router. Everything is good, but what about the load overloading? Since there are many routers, load balance process is very efficient in the distributed structure. I mean, this system works very well, and in addition to load balancing, it solves the single point of failure problem as well. For example, this router, this router, this router and this router are broken somehow. In this case, the internet continues to work properly, right? Only its efficiency decreases a bit. On the other hand, when there is only one router and if this router is broken, the whole internet crashes down, and this was very bad. So, I believe that consistency is very important for such a huge structure like the internet. And now, I want to show you a visual that shows the cables between different countries and different continents. With this visual, you will understand much better what the internet is. These cables are very important, especially for the communication of countries that there is an ocean between them. And this visual represents real life itself, unlike the simplified model we use. 99% of all international communication on the internet is provided by these 468 cable lines laid under the water. This is very crucial, guys. Some of these cables are only 131 kilometers long, while others are around 20,000 kilometers long, and so on. And the funny thing is, breaking one of these cables can cause the internet of a whole continent to go away in a flash time. In fact, it was happened such an event in 2018, and I want to show this on a different image, okay? I want you to focus on this red cable. This is an almost 17,000 long cable that starts in France and reaches South Africa. And this cable connects 22 countries on the west coast of Europe and Africa to each other and to the internet. And the internet of 10 of these countries crashed down when a fishing boat accidentally cut the cable, and I think this was a definitely tragicomic event. In addition to this, as you can imagine, this is not the only problem that happens to cables, because we are talking about 1 million kilometer long cables spread all over the world, so there must be something more. As a matter of fact, nearly 200 problems are encountered each year, and these are substantially related to the ships or natural disasters. And there is a funny reason that I prefer to use substantially word. Let me explain. In 2007, sea pirates stole 11 kilometers of a cable connecting Thailand, Vietnam and Hong Kong to each other, and they sold this long cable as scrap by dividing it, and I think this event is more surprising than the incredible infrastructure of the internet. Now I have back to the first slide because there is something I want to show here. These colorful cables generally represent intercontinental connections under waters. But for example, if you look at Russia land, cables are not visible on this image. Please don't be confused about it. Of course, there are cables and routers distributed all over Russia too. They are just ignored in this image. I mean, the main purpose of this image was to show you how devices from different continents are interconnected under the water, okay? Also note that all of these cables under waters are fiber optic cables because the fastest data transmission cable type is fiber optic cables, and intercontinental data transmission must occur at the highest speed, right? And another reason of why we don't use copper cables is when the length of the copper cables increases, the probability of errors in data transmission increases as well. On the other hand, even if the fiber optic cables are very long, they transmit the data to its destination almost without error. And this is another reason that why fiber optic cables are used over long distances. Great. I think it is important for you to understand what the internet really is. It is very vital to be able to visualize it in your mind. Because no matter what area of IT you are dealing with, you need to grasp this basic subject. Actually, there was something else I wanted to show in this lesson, but I don't want to extend this lesson any further. We will continue where we left off in the next lesson. That will be a very important lesson. See you guys in a moment. In this lesson, we are going to discuss how a packet moves over the internet. In this way, you will understand how two devices in different countries communicate with each other. We will see this on an example. Let's say this computer in LAN 1 wants to communicate with this computer in LAN 2, okay? In other words, let's assume that this computer wants to send a special packet to this computer. So, this packet must go to this router to exit from the LAN 1, because our destination is the out of LAN 1. I mean, it is a different network. Our destination is in LAN 2. And we can send our packet over the internet to LAN 2. And now, we are going to do this exactly. First, this computer sends the packet to the switch. After the switch receives the packet, the switch looks at the destination address of the packet and understands that it has to send the packet to the router. And after the router receives the packet, the router looks at the content of it and learns its destination address. Hence, it understands that it must send the packet to the internet, because the destination of the packet is in a different network than LAN 1. So, the router must send the packet to this router that is connected to, because this router is the key router for LAN 1 to connect to the internet. I mean, if this router needs to send a packet to the internet, it must send the packet to this router no matter what. There is no other option, right? And you can think of this link as the connection of LAN 1 to the internet. And if this link is cut somehow, the devices in LAN 1 cannot access the internet. It's that simple. After this point, things will get a little complicated, so please listen to me very carefully. After packet reaches this router, the packet has three options to go. This path, or this path, right? This is obvious, but the question is, which path is better option to go for the packet? And in order to answer this question, first, we need to discuss what the routing table is. Each router must have a special table inside called routing table, and after receiving a packet, every router looks at its routing table to learn which path it must send the packet. For this router, it should be this path, or this path, right? This is obvious. And if you are aware, firstly, the router receives the packet from one of its ports. I hope that you can imagine all these cables that come to the router are plugged into a port on the router. Very good. And after the router receives the packet, the router learns the destination of the packet and sends the packet to an appropriate port according to the information on the routing table. And we call this operation forwarding. As a result, every router needs to look at its routing table to learn which path it must forward the packet. In other words, we can easily understand that routing tables need to have information that which path a packet will go to, okay? It is very important to know this fundamental task of the routing table. Each router has a special processor, and information in the routing table is created by this special processor using many different algorithms. These algorithms determine the path that a packet must go, and the results of these algorithms are added to the routing table, okay? As a result, this router will look at its routing table and learn which path the packet must be forwarded, 1, 2, or 3. Meanwhile, when a router makes this decision, it always ignores the path that the packet came from, because it makes no sense to forward the packet back the way it came from, right? And let's say, according to the routing table of this router, the packet must be forwarded over path 3. And there we go. After that, this router needs to look at its routing table to decide which path the packet must go to. Assume that the routing table says the packet must be forwarded over path 2. So the packet will go to this router, right? And there we go. If you are aware, the event is always the same, and it will continue to be the same in every router until the packet reaches LAN 2. Anyway, let's keep going where we left off. This router must look at its routing table to determine which path the packet will be forwarded. Let's say the router chooses path 1, so the packet will go to this router, right? Wonderful. And at this moment, please listen to me very carefully because there is a tricky part here. When you look at the paths for the current position of the packet, you probably think of the most reasonable option as path 2, because the shortest path to be able to access this router that is connected to this router seems to be path 2, right? And if we choose path 1, for example, we have to go to this router first, and from here we can go to this router. Or if we choose path 3, we will go to this router first, and from here we can go to this router similarly. But if we choose path 2, we can go directly to this router, and this is what we want. But is this really the case? Let's see together. First of all, never forget that routers always want to deliver the packet to its destination as fast as possible. So, if this router chooses path 3 instead of path 2, it may seem unreasonable to you at the beginning. I understand that because you decide with a very simple logic. You are just using your eyes. However, routers use many algorithms when creating their routing tables, and these algorithms have many variables. Routers have to take into account many situations when they are creating routing tables. For example, let's call every router as a point in this structure, okay? So, when routers create their routing tables, they are not only concerned with the number of points when choosing the shortest route to the destination. This is really very important, and I want to give an example to you to understand this subject better. In some cases, routers control the traffic of their links they are connected to, and if a path is too busy in terms of packet density, the router will not send the packet over that path. For instance, there may be an excessive density on the path 2 line even if it seems the best option, okay? And since the router knows this line is too busy, when creating its routing table, it may decide that it is more convenient to send the packet over path 3 instead of path 2. And we call this situation congestion control, okay? I think that I could get to the point. As a result, the router sends the packet over path 3, and here we go. As you can see, the number of points that the packet went through has increased. However, with the selection of path 3, the packet can probably reach its destination faster. Don't forget this. And after this moment, let the packet go to this router, and there we go. And this router knows that the packet will go to the LAN 2, and it sends the packet to the router in the home, okay? By the way, you can think of this line as a straight line like that. And this router knows that the packet came to this computer, so it sends the packet to the related computer. Wonderful. As you can see, two devices located in distant areas basically communicate with each other thanks to the internet. We can communicate in milliseconds with a device on the other side of the world thanks to the internet. I am talking about milliseconds, guys. This is a huge thing. And that's the main reason of why the internet is one of the most important things that mankind created. I hope I was able to explain intuitively what the internet represents. However, there is also something else very important that I have to say. I want to tell you the bookish definition of the internet. The internet is the network of the networks. Let me repeat. The internet is the network of the networks. I believe that you got this, but I would like to make this definition more meaningful to you. Firstly, think about your own home. Maybe you have a lot of devices that can connect to the internet. For example, computers, mobile phones, televisions, game consoles, tablets, and many more. Similarly, most people have many devices with an internet connection in their home just like you, right? In the same way, you can think about a company or an enterprise that has a huge number of devices, and you know that there are many companies and enterprises in all over the world. So, as you notice, there are many small or medium-sized LANs spread all over the world. And all these LANs on the visual represent these networks. As a result, the combination of all these networks stand for the internet itself. This is very important. The combination of all these networks stand for the internet itself. In other words, we are talking about a huge system in which almost all electronic devices in the world use to communicate with each other. By the way, there's a very important part here to understand on the visual. We called this structure that is in the middle of the visual as the internet, and you will see such a representation in many resources. You can usually see a cloud logo in order to represent the internet. But in fact, the internet is this big structure you see, formed by a combination of all these networks and this structure in the middle, okay? This is very crucial, guys. What I am trying to say is, when you only see such a representation, you should think that there are millions of LANs that are connected to it, even if these LANs don't appear in the visual, okay? And the internet is a huge system that includes all LANs in the world. So, I hope that you understand better the reason of the bookish definition of the internet. The internet is the network of networks. Wonderful. And you can think of this structure as the heart of the internet. For example, when we connect this LAN to the heart of the internet with this cable, this LAN will be included in the internet, and it can communicate other devices that are connected to the internet. You catch the idea. So far, we have learned what the internet is and how important routers are. But what exactly does connecting to the internet look like from a computer's perspective? And we are going to discuss this question in the next lesson. See you guys soon. Bye. Now, we are going to discuss the meaning of connecting to the internet from the computer's perspective, and I believe that it is very important to understand this event. Assume that we are in a home instead of an office and we have only one computer. Therefore, to be able to connect to the internet, what we only need is a home router, isn't it? There is no need for a switch since we don't have other devices to connect to each other in this home. Very good. By the way, if we want, we could use a router device instead of a home router device. Because if you are aware, we want to use only the router feature of the home router. We don't need to use the switch feature of the home router, right? Because there is only one computer in the environment. I believe currently you know which device actually does what. This should be logical to you. Therefore, I will assume that you know what basic networking devices are doing from now on. And so far, you have learned that the connection situation of the internet is determined by whether the related computer can send a packet to the internet or not. And now, I will try to make this situation more meaningful to you. You are watching this video on the udemy.com website, right? I mean, let's say you are turning on your computer and entering udemy.com on your favorite web browser. Then you click on the video you are watching right now or any video you want to watch. And as soon as you click on one of these videos, your computer creates a packet and sends this packet to udemy.com over the internet. The packet firstly is sent to home router, and then the home router sends the packet to udemy.com over the internet. And we can think of this green packet as your request message to udemy.com. A request message gives information to udemy.com about you want to watch the related video, okay? This is very crucial. And after udemy.com receives your request message about watching a specific video, it naturally realizes that you want to watch a video. Hence, Udemy sends the related video to you over the internet, and there we go. These red packets represent the pieces of the video that Udemy sent to you. In other words, the video you are watching right now. By the way, there's a very important thing about this process. Let me explain. While you are watching any video on Udemy, Udemy sends it to you piece by piece, and we call this process streaming. I think you have heard of this concept before, and with the help of streaming technology, you can watch the videos uninterruptedly or without any problem. And to be able to show this piece by piece sending process better, now I have opened a random video on udemy.com. You can see that the video is being sent to my computer from udemy.com piece by piece. Thanks to the ability to send videos piece by piece, we can watch the video without requirement for all the video to reach our computer. For example, imagine you want to watch a 1-hour video and assume that your internet speed is so slow. If you couldn't watch this video before the whole video reached your computer, it will be very bad for you, right? Fortunately, the process doesn't work like that, okay? And in addition, this transmission time varies depending on the speed of our internet. The faster our internet speed is, the sooner the video will reach our computer. It's that simple. I hope in this way you have a better understanding of what these red packets are. Great. As a result, connecting to the internet refers to you can send some packets to the internet and you can receive some packets from the internet. And here, the router or home router in this situation plays a very important role. The home router gives the packets it receives from the computer to the internet and gives the packets it receives from the internet to the computer. In summary, packet transmission is the basis of connecting to the internet or communicating with a computer on the other side of the world. Meanwhile, when we enter udemy.com, we communicate with very powerful computers that actually belongs to udemy.com, and we call these special computers server. Servers do not differ fundamentally from normal computers. However, since the servers will exchange packets with thousands of normal computers at the same time, servers must be much more powerful computers in terms of hardware compared to normal computers. Because as you know, too many people access udemy.com at the same time. Too many people access servers of udemy.com at the same time. And at this moment, let me tell you what I mean when I say servers of the Udemy. If you remember, we talked about the importance of the single point of failure and load balancing before. And this is true for servers of Udemy too. There is not a single Udemy server in the world. Udemy has a lot of servers distributed around different parts of the world. The location of one of these servers is the best for you, and you communicate with this best suited server. It's that simple. As a result, when you want to enter udemy.com, you are actually communicating with one of the suitable Udemy servers for you. So, while some of you communicate with the same server, some of you will communicate with a different server. But at the end of the day, you will all get the same content. Therefore, thanks to distributed servers, Udemy prevents single point of failure and provide load balancing. Please think about it a little, okay? By the way, of course, there are many details behind the transmission of packets, but you can think of it in this way as the simplest logic. And that's all I need to say in this lesson. See you guys soon. Bye. In this lesson, we will shortly talk about the Wide Area Network, or briefly WAN, which is a very important type of network for the internet. In a simple manner, you can think of WAN as a network consisting of a combination of different LANs. For example, with the combination of these two LANs, we can create a WAN, or combination of this LAN, and this LAN, we can create another WAN, okay? And in order to understand better the logic of WAN, we can talk about the company example. Let's say we have a growing company and we opened some offices in different parts of the world, and we want these offices to be in the same network even if they are far apart. And this is where the wide area network comes into play. By using WAN, we can create a special network for our requirements. Let's say this is one of our LAN and this is our another LAN, and they are located in different parts of the world, and we want to create a WAN for our company by using these two LANs. But the question is, how do we do that? Let's see. Let's say our boss wants us to establish a special network for these LANs. He wants the computers in these two different offices to work as if they are in the same environment. So, our guy is WAN. If we create a WAN, these LANs can communicate as if they are in the same environment. But there is an important point to consider here. Thanks to the internet, we can already enable these LANs to communicate, right? As you know, the internet stands for the network of networks. This means that the internet itself represents connecting millions of LANs together. Hence, if these LANs are already connected to the internet, computers in LAN 1 and computers in LAN 2 can already communicate over the internet. This is obvious. So, the question is, if these offices can already communicate with each other over the internet, why we need another special network as a WAN? Please be careful. Communication over the internet directly and communication over a special WAN belongs to a company is a whole different thing. So, I want you to think about that question for a short time and try to answer it. If you have noticed, the internet is a public network. The internet has no owner and it belongs to everyone. Any person can connect to the internet whenever and wherever he wants. For this reason, it is obvious that this public and huge network can have security-related problems in information transfer between different locations. Hackers are everywhere and they are in this public and huge network too. And to be able to answer the question I just asked better, I want to give you a very good example. Let's say this computer wants to send an important file related to the company to this computer. And after the file is sent to this computer, there will be no any problem because this transmission process took place within this LAN. This LAN is a private network for this office. An outsider cannot directly access this LAN without your permission. This is very important. Hence, file transmission operation in this LAN is a secure operation in general. Everything is good so far. But what would happen if this file was sent to the other office over the internet? Let's see. Now, the scenario is the same again. We need to send a file related to the company, but this time we must send this file to the other office of the company. As you can see, the file passes through the public network, isn't it? And this is where the problems appear. Just think about it. This part of the internet is an absolute public network. This means that if you send the file over the internet like that, there is no guarantee that no one from the outside can't see this file, or worst, no one from the outside can't change this file. As I said before, hackers are everywhere, and the possibility of these issues are generally not low. Hence, it is important to remember that there is a possibility for a problem when you send this file about the company over the internet directly. Especially if it is a very important file about the company, it is very vital to be careful. And a special WAN for the company is a solution to such problems. In general, setting up a WAN is a costly and not easy task, but fortunately, there are various methods of setting up a WAN, and now we will only talk about the most popular and cost-effective WAN method, and this method is WAN by using VPN. I am sure that you have heard of VPN before. It stands for Virtual Private Network, and people usually use VPN to access restricted websites because VPN ensures our anonymity and it encrypts our data before sending the packet. Hence, this gives us high security in general. And while creating WANs by using VPN technology, we take advantage of these features of VPN. But the most important feature you should know about VPN is the tunneling. This feature of VPN provides privacy, anonymity and security to us by creating a special network connection over a public network. This is really very important. I want to repeat this again. VPN tunneling provides privacy, anonymity and security to us by creating a special network connection over a public network. However, frankly speaking, a physical tunnel isn't created here. This is very crucial. Tunneling technology makes the packet acts as if it is going through a physical tunnel. But I want to repeat it again. This is not a physical tunnel. This tunnel visual just represents the high security connection between LAN 1 and LAN 2. You can think of it in this way. This tunnel visual just stands for the high security for the connection between these routers. It's that simple. By the way, of course, the packet will pass through many routers on the internet in order to reach its destination, just as you have learned before. However, since VPN uses tunneling, it will be almost impossible to interfere with this packet from the outside. Great. I hope that you got the tunneling conceptually, but I want to take a closer look at it. So first, we sent our file to the router, and there we go. And at this moment, there will be some changes on the packet. But before doing these changes, first of all, you should know that VPN tunneling is set up between these routers. This is very crucial. And we call this site-to-site VPN. This method is very popular while creating a WAN between offices. And thanks to the tunneling, our file safely reaches LAN 2, But the question is, if tunneling is not a physical tunnel as shown in the picture, what exactly is it? Let's see. I will use an analogy to explain this. Let's say you need to send a letter from LAN 1 to LAN 2. So, you should give the letter you wrote to a postman, right? The postman can take this letter to its destination. And suppose you are not putting this letter in an envelope. This means that the postman can read the letter if he wants. This is obvious. You can think of the postman in this example as the public internet. On the other hand, if you had put this letter in an envelope first and gave it to the postman in this way, the postman wouldn't be able to read it. This is obvious. Hence, the process of putting the letter in an envelope represents the tunneling itself. So, in the real scenario, we had to put this yellow packet into another packet. And there we go. Assume that the yellow packet is in the red packet. It's just like putting the letter in an envelope. That's the whole idea about tunneling. Wonderful. And at this moment, I want to ask you a question. And my question is that, is this packet really unsafe right now. I mean, can't the postman open the envelope and find out the information in it if he really wants to? Just think about it. You got the point, right? Even though we have increased the security of the packet by applying tunneling, there are still some problems. And this is where encryption comes into play. Suppose that you encrypt your letter in a way that only people working in your company can understand. In this case, even if the postman opens the envelope, he cannot obtain the information because he will see non-understandable data. He will not understand the encrypted information. So, what we have to do is very simple, right? We must encrypt the original packet before putting it into another packet. So, let me back one step on the animation. And for this scenario, we encrypt the yellow packet before putting it in the red packet. And then we put this encrypted packet into the red packet. And finally, this packet is sent to LAN 2 over the internet safely, and there we go. It's that simple, guys. We encrypted the original packet and put it in another packet. Thus, we maximized the security of the packet. Okay? The term of tunneling comes from here, because packet is safe as if it was moving in your own private tunnel. I hope that I made this concept understandable to you. And at this moment, the router needs to get the original packet. And to be able to do this, the router first eliminates the outside packet, right? And then it needs to decrypt the encrypted packet so that it can obtain the original packet. And after the router gets the original packet, it looks inside the packet and learns its destination and sends the packet to its destination. And there we go. As a result, with the help of the WAN, by using VPN, we can securely send company-related information from one LAN to another. But never forget that there is no such thing as 100% security. This means there may be always a security vulnerability for every system. However, currently, WAN networks built by using VPN technology are quite satisfactory in terms of both budget and security, okay? I believe everything is good so far, but some of you curious can think about a question. You probably think like, I constantly use the internet in daily life. I send mail to my friends. I use e-commerce website and I do all of these over the internet. So, since the internet is a public network, are all these operations insecure? The answer is both yes and no. Let me explain. Assume that you want to make an operation on Amazon.com, and let's say you had to enter some information about your credit card while purchasing a product. Since this information will be sent as a packet over the internet to one of the servers of Amazon.com, we absolutely don't want anyone from the outside to see the information about our credit card. As a solution to this, an end-to-end encryption method is used between our computer and the destination server. And since the packet is encrypted, nobody from the outside can see the information about our credit card except the server of Amazon.com. This is the main logic behind the end-to-end encryption. Only the endpoints can decrypt the packet and obtain the original data, okay? However, this kind of encryption was not used in the past, and this situation made it easy for hackers. Imagine that the information about your credit card was directly obtained by a hacker in pure text. This is terrible, right? But thanks to end-to-end encryption, we eliminate this problem. And finally, I am going to ask you a question, and then I am going to finish the lesson. Now, you know what WAN is, right? In summary, WAN represents the networks we create by combining different LANs. In this case, my question is, what is the largest wide area network in the world? The answer comes to your mind rapidly, isn't it? The internet itself is the largest wide area network in the world. However, I want to remind you again, please note that a company's WAN created with VPN is different from the internet. while one of these vans is completely special to the company, the internet is owned by everyone in the world. And yeah, that's all I would like to say about WAN. See you guys soon. We have learned a lot of information about network devices until now, and in this lesson, we will look at a few more cases by using these devices. Let's say we have two offices belongs to the same company, and suppose that there are 100 meters between these offices. If you are aware, this distance is very short. In this case, what I am wondering is whether or not we can connect switch 1 and switch 2 directly to each other to create a LAN. And the answer is we can definitely do this. Because as you know that we use switches to create LANs. Therefore, we can create a LAN by connecting these switches to each other even if they are not in the same environment. But please note that the distance is very short between these offices. If this distance were not too short, it is impossible to connect these switches and create a LAN. Meanwhile, these types of LANs can be called Campus Area Network or briefly CAN, since these types of networks are generally used on university campuses. Okay? On the other hand, you know that we can also connect these two offices by using WAN with VPN. But please note that WAN and LAN are different kinds of network types. This is important. And you can see the packet sent with tunneling in the animation. And there we go. Yep. I believe so far everything is good, but I want to ask you a question. Which one do you think is more secure? WAN with VPN or LAN created by connecting switches directly? Please think about it for a short time and try to answer it. The answer is so simple, isn't it? A LAN is always more secure than a WAN, because in the communication within the LAN, the packet never passes over the internet. The packet always moves on our own cable. On the other hand, even if the packet is protected in the WAN, the packet still passes over the internet. And as you know, there is never such a thing as 100% security even if the packet is protected with tunneling and encryption. So, to summarize, both of these methods are secure, but LAN is more secure. This is obvious. However, there is a condition that a WAN is almost as secure as a LAN, and we call private WAN for this type of WAN. By the way, we haven't talked about this WAN type before. I mean, this is different from WAN with VPN because the line between offices is dedicated for the company. You request this line from the ISP and give a special money for this line. Thus, the ISP gives you a private line that only your company can use. We call the WAN created in this way as private WAN, okay? And please remember that we were using public internet network in WAN with VPN, and that's why we also call WAN with VPN as public WAN. This is very crucial. In addition, even if private WAN sounds great at the first glance, it can be quite costly. For this reason, it makes sense for an average company to prefer public WAN instead of private WAN. You know, public WAN provides us security that we definitely cannot underestimate, right? Wonderful. Now, I want you to pay attention to one point. Some of you may have already noticed this, but it will be good to mention in any case. We use switch devices to create a LAN while we use routers to create a WAN. This is very vital. I want to repeat this again. We use switches to create a LAN while we use routers to create a WAN. This means we cannot create a WAN by using switch devices because a WAN fundamentally represents connection of different LANs. With the help of WAN, different LANs can act as if they are in the same environment. And you know that if we want to connect different LANs, we definitely need a router for this task. you got the point. And now I want to talk a little bit about the router. Until now, I have always explained the router as an internet-related device. However, it isn't. The main task of the router is to connect different networks. That's it. You should realize that these networks may be in different parts of the world or maybe in the same office. It really doesn't matter. And in this slide, you can see that two different LANs in the same office are connected to each other thanks to the router device. Suppose that one of these networks is related to the marketing unit of the company and the other related to the software unit. And as you know, if we want different networks to communicate with each other, we should use a router. In the animation, you can see that LAN 1 and LAN 2 communicate through the router. And there we go. Great. And here, I want to give you additional information about the router. I want you to focus on the cables of the router. If you are aware, each cable is connected to a different network. I mean, one of the cables is connected to LAN 1, one of the cables is connected to LAN 2, and one of the cables is connected to the internet. This is the case for the router. The router connects different networks. For this reason, each cable connected to a port on the router represents a different network, okay? By the way, you may have wondered why different networks are needed within the same office. As a matter of fact, this is a common situation in real life. I mean, you may want different units in the office to be in different networks. This might be absurd for an office with 4 computers. However, imagine an office with 50 computers in it. Dividing these computers into units increases hierarchy and order. Never forget that. As you can see, the basic principles are the same everywhere. By using these basic principles, we can enable devices in different parts of the world to communicate, and we can enable devices in the same office to communicate. Both of them represent the same task. I think you understand this concept very well. And that's all I want to say in this lesson. See you guys soon. In one of our previous lessons, I told you we purchased this cable that came to our home from ISP, but I haven't mentioned what exactly ISP is. And in this lesson, we are going to discuss what is the ISP and why it is so important. The Internet Service Provider, or briefly ISP, is responsible for the transmission of packets from one location to another. If you remember, we have learned that there are a lot of routers in the heart of the Internet. I'm talking about this structure. And you can think of the ISP as the mechanism that controls all these routers in this structure. For example, there are actually many routers in this global ISP. Similarly, there are many routers in this regional ISP. But to simplify the concept, I didn't visually show the routers within the ISPs. However, I want you to imagine that the routers distributed around the world are controlled by these ISPs. This is very crucial. Think of it as if each ISP controls specific routers, and packets are sent from one location to another location over these routers. We previously talked about how the packet travels from one point to another via routers. Understanding this situation is the first condition to understand the ISP. What I am trying to say is, certain ISPs are responsible for certain routers. I want you to imagine that every ISP you see in this picture is responsible for certain routers, okay? But I am removing them from the visual for the simplicity of the concept. In addition, the ISP model you see here is a simplified model, but even if the model is simple, it is enough to understand the most important parts of the concept. Let's start with basic definition of the ISP. ISPs represent companies that serve us so that we can connect to the internet. And of course, they charge a certain fee for this service. You cannot connect to the internet without an ISP. Think of ISP as the structure that allows you to connect to the internet. And ISP is not a single structure. There are hundreds of thousands of ISPs in the world, and all these ISPs come together to form the structure you see in the visual. There is few ISP in the visual, I know that, but I can say that there are hundreds of thousands of ISPs in real life. The most common ISP type in the world is local ISP, and now I want to start with it. The first step of connecting to the internet is to communicate with the local ISP. And local ISPs are generally responsible for small area communications, for example, the communications of two different LANs in the same neighborhood, or communication of LANs located in neighborhoods close to each other. Let's say we live in the USA and these two homes are located in the same neighborhood. If this computer wants to communicate with this computer, the connection is provided directly over this local ISP. This is obvious. You can see this on the animation. The packet passes through different routers at the local ISP and reaches its destination. But in general, since the local ISP is responsible for the communication of small areas, the packet can also pass through only one router before reaching its destination. You can think of this local ISP as the ISP that only connects LANs within a neighborhood. Of course, a local ISP can connect different neighborhoods, but in this scenario, let's say it doesn't. Therefore, one router can be enough to connect them. You got the point. And in this visual, you can see an example of a small local ISP office, and we call these offices point of presence, or briefly POP. In fact, routers distributed over the internet are included in these POPs, and in this POP, in other words in this office, routers are on the left side. In addition, you have probably noticed that there are other devices than routers, because sometimes we must do different configurations with different devices. Hence, a POP must have routers, switches, servers and so on. But the device we use to connect different networks to each other is the router. For this reason, we will only focus on routers. And in our previous lessons, the routers on the internet visual were actually representing POPs spread over the world. And in order to explain this better, I want to talk on a different image. But in this image, I want to think of different houses and offices connected to local ISP2 and local ISP3. I mean, we won't talk about these homes. You got the point. And there we go. As you can see, a home and small office connect to a POP over local ISP2. So, this POP is the first point to be able to connect to the internet for this home and this office. This should be clear to you. By the way, if you are aware, local ISP2 has 4 POPs. You might think that thanks to these 4 POPs, local ISP2 connects different neighborhoods, and in this way, LANs in different neighborhoods can communicate over local ISP2 effectively. And from here, we can draw the following conclusion. Some local ISPs can have more than one POP. However, some local ISPs can only have one POP. This depends on the size of the local ISP. For example, if a local ISP connects 4 different neighborhoods, it may have 4 different POPs. But if a local ISP connects only one neighborhood, it has only one POP. You catch the idea. And if you want to do more detailed studies on this topic, you will see many resources on the internet with router icons. You should be aware that these icons actually represent the router within the POP. There are many POPs distributed all over the world, and routers are in these POPs. It's that simple. At this moment, I want you to imagine that there are hundreds of thousands of local ISPs in the world, and these local ISPs connect to regional ISPs that are larger than them. This means that different local ISPs communicate over regional ISPs. For example, local ISP2 communicates with local ISP3 over the regional ISP1. As a matter of fact, you can think of local ISPs connect neighborhoods and regional ISPs connect cities in a country. It's that simple. I want to repeat this again. You can think of local ISPs connect neighborhoods or small areas and regional ISPs connect cities in a country. Okay? Meanwhile, there is one regional ISP in this simplified model we use, but in real life, a country can have many regional ISPs, and all local ISPs and regional ISPs combine in order to create network of a country. In summary, the first step to connecting to the internet is local ISP, and this line represents the line we purchased from the local ISP, right? Every home or office must purchase such a line from the relevant ISP to connect to the internet. And if you examine your home router carefully, you can see the cable coming from your ISP. Wonderful. Now, let's suppose that this computer and this computer want to communicate with each other. By the way, these two homes are located in the USA, but they are in different cities. As a result, they are connected to different local ISPs. This is obvious. So, in this situation, how will this local ISP communicate with this local ISP? Let's see. In fact, this is where the regional ISP1 comes into play. In general, the regional ISP is engaged in the communication of devices in the same countries but in different cities. If you look carefully at the animation, local ISPs communicate over the regional ISP. This is obvious, right? And there we go. And at this moment, some of you may be wondering why there is no direct link from local ISP2 to local ISP3. This is an unexpected question. Just think about it. If we connect local ISPs directly, the hierarchy is broken. I mean, you see very few local ISPs in this scenario, but in real life, there can be many local ISPs even in the same city. And if we connect them all together, complexity will definitely occur. And we don't want to increase the complexity of this system. It is already quite complex, isn't it? And that's why we use a central hierarchical ISP structure as you see in the visual. With the minimum number of connections between ISPs, we ensure that all ISPs communicate with each other. It's that simple. So far, we have talked about the local ISP and regional ISP. Also, the computers that communicate with each other were always in the USA. But what if computers in different countries want to communicate with each other? And this is where the global ISP comes into play. You may think that the global ISP connects devices in different countries in general. As you know, there is an ocean between the USA and China. So, if a device in the USA and a device in China wants to communicate, it must be a global ISP that provides this connection. We cannot connect these two devices with only local ISP and regional ISP. And as you can see in the image, there are multiple global ISPs, and these global ISPs are the part of the hierarchy, and by using them, these two computers can communicate with each other. Let's assume that this computer wants to communicate with this computer. In this case, the packet will first go to the local ISP2, and then go to the regional ISP1. And the packet has two options at this moment, this path or this path. In other words, global ISP1 or global ISP3. I hope you understand that this selection is determined by the routers in the regional ISP1. Each router makes a choice, and as a result of these choices, the router's path is determined. Let's say the packet will be forwarded to global ISP1, and there we go. By the way, another packet that will pass through regional ISP1 may go to the global ISP3 next time. Who knows? You catch the idea. Anyway, afterwards, let's say that the packet will be sent from global ISP1 to global ISP2, and there we go. And at this stage, the packet can be sent to local ISP6 or directly to the regional ISP2 or global ISP3. Either way, it will reach its destination. What I am trying to say is, the packet can follow different paths, and I want to show you some of these paths. For example, from global SP2 to local SP6, regional SP2, local SP7, and destination, or from global SP2 to direct regional SP2, local SP7, and destination, or from global SP2 to global SP3, regional SP2, local SP7, and destination again. All of them are suitable paths. You should also have noticed a situation here. If the destination of the packet was this home, the packet could reach its destination directly over local SP6 without going over regional SP2. This means that some local SPs can directly connect with global SPs without a regional SP. This is very important. As you know, local SPs represent small companies, and in some cases, these small companies may want a direct connection with a global SP to provide a faster internet experience to its customers. Actually, there are two ways for this kind of connection in general. If a local SP connects directly with a global SP, its location can be very suitable for this purpose. I mean, related global SP can already have an infrastructure on this location. However, if the related global SP doesn't have an infrastructure in this location, a lot of extra money must be paid for this connection by the local SP company to the global SP company. You catch the idea. And for this packet on the global SP2, let's say it will go to the regional SP2 instead of local SP6 or global SP3, okay? And from here, packet will go to the local SP7, and there we go. As you can see, local SP7 is connected directly to the destination LAN. Therefore, local SP7 knows that where it will send the packet. And finally, the home router receiving the packet sends it to the destination computer. Voila! As a result, you have learned how computers in two different regions of the world communicate over the internet. You also learned the relationship between the internet, routers, and ISP with each other. And in the next lesson, we are going to cover two more scenarios related to the ISP concept. See you guys in a moment. Let's say we are in Belgium. This is our home and we want to connect to a newly established website called abcx.com. The owners of the website have limited financial power. For this reason, they have only one server on the USA. So, to be able to reach abcx.com, our request message must pass over at least one global SP. This is obvious. You can see the whole process on the animation. And after the server of the abcx.com receives the request message, in exchange for it, abcx.com creates a response message. This response message contains information about the web page we want to enter. It includes images, videos, HTML file, and everything related to the web page. Meanwhile, if you don't know what an HTML file is, you can think of it as the skeleton of a web page in a simplest manner. And after generating the response message, the server must send it to us. However, the path preferred by the response message will be different from the path preferred by the request message. Please pay attention to this on the animation. There is no way to know the exact path of a message beforehand, since routers can make different choices each time. I mean, the path for a message is always determined on the way. Never forget that. And as soon as we receive the response message, the website appears in our web browser. In summary, when you want to enter a website, you first send a request message to the server of website, and the web server receiving your request message sends you a response message which contains all information about the web page you want to enter. And when this message comes to you, your web browser learns all information from this response message and displays the related web page in your web browser. And the surprising thing is, Every time you want to enter a website, this process happens again. However, since this process takes place in milliseconds, you don't realize that there are complex operations in the background. And now, let's try to enter google.com instead of abcx.com and see what happens. Google is quite different from abcx.com since it is a giant company. For instance, unlike abcx.com, Google has many servers distributed all around the world. And with this distributed server structure, Google provides a much more efficient and fast service to its customers. And let's say one of these servers is not far from our home. Therefore, when we want to enter google.com or when we want to get any service from Google, we will probably connect to this server which is close to us, okay? For this reason, the process will be much faster. In fact, this is the main reason why big companies put many servers in different locations around the world. They want customers to communicate with them in the fastest and most efficient way, and the distributed server structure is a great solution for such a desire. I believe you catch the idea. So, when we want to request a service from Google, our request message will go to this server close to us. You know that how the packet reaches the related server with the help of ISPs. And you know that what will happen after this stage. Google sends us a response message related to the servers we request. However, the time for Google to communicate with the customers is sometimes not satisfactory for Google, and Google wants to increase this speed in general. Fortunately, Google has a very good solution for this kind of issue called peering. But what exactly is peering? Let's see. Peering is the technique which Google establishes a direct connection with an ISP to provide faster access to its servers. As you can see on the animation, Google connects directly with the local ISPs. Thus, when we want to get a service from Google, we will be able to communicate directly with Google servers without using ISP infrastructures. In this way, Google can communicate with the customers much more effectively and quickly. At this moment, everything is good. But what about security? Since the number of public POP that packets pass through decreases thanks to peering, security increases so much. The packet goes directly to Google via local ISP. In other words, the packet does not use public ISP infrastructures to communicate with Google. Remember that security is very important to large companies, and it is obvious that this direct connection decreases the possibility to be obtained for the packet from the outside. Wonderful. And last but not least, I want to give you an example. As you know, YouTube is owned by Google. So, when you want to watch a video on YouTube, you are actually using Google's distributed servers around the world. And you are all aware that YouTube works very efficiently. When you want to watch a video on YouTube, you can watch it very well. You aren't be interrupted whatsoever. The main reason for this is the distributed server structure and the peering infrastructure of Google. On the other hand, you may sometimes see freezes and interruptions while watching videos on Udemy, because Udemy's infrastructure is not as strong as Google in general. Of course, Udemy also uses a distributed server structure, but this number is probably not as many as Google. This is obvious. In addition, Udemy doesn't use peering, and you know that peering is a very efficient technology. Especially, it increases the streaming quality and speed a lot. But I can say that Udemy did a significantly good job overall, because serving millions of people at the same time is a really challenging engineering problem, okay? In summary, peering is a very effective structure is used by giant companies like Google, Amazon and so on. You got the point. And finally, I want to give you some general information about the ISP. As you know, global ISPs are responsible for the international communication. I can say that Although definitely not as many as the regional ISP, there are a few global ISPs in the world. And you can guess that the technical reasons for not having only a single global ISP in the world. We have talked about similar things before. But in addition to these reasons, like load balancing and efficiency, there are also some financial reasons for this. I mean, setting up a global ISP company is a very costly business at the beginning, but it makes its owner a lot of money. You know what I am saying, right? If you have a lot of money, establishing a global ISP company is a good choice. It will probably make you smile with time. By the way, we also call the internet backbone to the network that global ISPs set up with each other. Familiarity to internet backbone term can be useful for you in the future. In addition, there are structures called internet exchange point in order for the internet backbone to work synchronously and for global ISPs to communicate with each other more efficiently. And we briefly call these structures IXP or IX. Never forget that. And the last thing I want to mention is that you don't have to connect to a local ISP in order to connect to the internet. You can directly connect to a regional ISP or global ISP if these ISPs have a service for your location. This means that you can learn which ISPs are serving where you live and make your choice according to this information. It is absolutely your decision to choose the ISP service you want, okay? For example, let's say this is our home and we connect to the internet via local ISP too. However, if we request, we can also connect directly to the internet via regional ISP1. This is possible. What I am trying to say is, if you want to get your ISP service from a certain company, and if this company doesn't serve your location, you can contact the company and talk about what you can do. If you give the required money to the ISP company, most regional ISP and global ISP can provide you the service you want. That's it. But for normal users, this is very unnecessary. Normal users only need to choose one of the ISP services in their location and benefit from it. On the other hand, if you want to set up a local ISP company, such a move may make sense. Wonderful. And we talked about the ISP in general. I think you got a lot of good information. But if you want, you can do more research about the ISP on the internet. However, that's all I have to say in this course.